In this video, we are going to learn about arithmetic sequences. Arithmetic sequences is when the difference between successive terms is always the same number. We call that a common difference. In this arithmetic sequence, the common difference is 2. Now, it's pretty easy to see that you can add 2 to get from one term to the next. However, when it's not easy to determine what that common difference is, you take the second term minus the first term. So the second term minus the first term. And that gives you your common difference of 2. You can also take the third term minus the second term. So you can pick any term. If you already know that it's an arithmetic sequence, you can take any term and subtract the previous term, and that will give you your common difference. In this case, it is 2, and that common difference is signified by D for difference. Now, I like to call this the linear rule. When you have an arithmetic sequence, we will have a rule that will tell you how to find any term in that sequence, and that is a linear rule. Now, although this video is not going to focus on geometric sequences, it is helpful to know the difference between an arithmetic sequence and a geometric sequence. A geometric sequence is when the ratio of successive terms is always the same number, and that's what we call a common ratio. So we're going to take the second term divided by the first term, and that's our common ratio. And we call that common ratio R. 6 divided by 2 is 3. So the common ratio is 3. We can also take the third term and divide that by the second term. And the third term, 18 divided by 6, is also 3. So what we find is that to get from one term to the next, we're not adding the same number, but we're multiplying by the same number. And in this case, the common ratio R is 3. Let's work with arithmetic sequences. The nth term of an arithmetic sequence, let me go back real quick because I did say the linear rule, and I want to say right here, this right here is the exponential rule, which we'll do in the next video. But I do want to bring that up because I'm going to use that again. So I want to make sure that that's in your notes. The exponential rule is what we call the geometric sequence. So the arithmetic sequence, let's go back here, and that's the linear rule. So the linear rule. Just keep thinking linear rule. And when you think linear, you might be thinking mx plus b, right? mx plus b, indeed. So the nth term of an arithmetic sequence, the nth term of an arithmetic sequence is denoted by a sub n. The first term is a sub 1. So that's the value of the first term. N is our unknown, and D is our common difference. Now you can also refer to N as the number of terms. So if we're looking for the 15th term, N would be 15. The common difference is the slope. It's your slope of your linear rule. So here's an example. We're going to write the simplified rule. For finding the nth term for finding the nth term of the sequence given by 7, 3, -1, -5, ... So my first step is to determine the common difference. So determine your common difference, which is D. So it's denoted by a lowercase d. So my first step is to find my common difference. 3 minus 7 is -4. -1 minus 3 is -4. -5 minus 1 is -4. So our common difference, D, is 3. Now we're going to identify A sub 1. So A sub 1 is the value of the first term, which is 7. Our formula is A sub n is equal to A sub 1 plus the common difference D times n minus 1. I can substitute in 3 for D and 7 for A sub 1. And when I do that, I get A sub n equals 7. I don't know why I said 3. I'm not sure why I said that the common difference was 3. That's sad. The common difference is -4. You're probably looking at me the whole time, or not looking at me. You're probably looking going, where did 3 come from? The common difference was definitely -4. I think when I said 3 minus 7, I said -4. -1 minus 3, I said -4. But then I had that 3 maybe in my mind. It is not 3. It is -4. So I'm going to put that -4 right here. So 7 is the value of our first term, 7, and then -3 is the value of D, and then that's multiplied by n minus 1. Now remember, you have to multiply before you can subtract. So as much as we want to subtract 7 minus 4, we can't. So that's 7 minus 4n plus 4, which gives us -4n plus 11. -4n plus 11. And when it said the simplified form, it meant distribute the -4 and combine like terms. And that's how you get your arithmetic rule in simplified form. So here we're already given the arithmetic rule in simplified form. We need to find the common difference, D. So what is the common difference? And then what are the first 4 terms? What are the first 4 terms? Well, the common difference is your slope. So our common difference is 3. And now we need to write out the first 4 terms. The value of the first term is A sub 1. So I use my rule, and in place of n, I'm going to put 1. I'm going to multiply and add, which gives me 4. 3 plus 1 is 4. The value of the second term, I'm going to put a 2 in for n, and that gives me 7. The third term, I'm putting a 3 in, and that gives me 10. And then the fourth term, I substitute a 4 in, and that gives me 13. I could also find the first term, and then knowing that the common difference is 3, just continue to add 3 to get all 4 terms. Okay, we want to find the nth term of the arithmetic sequence A sub n whose initial term is a sub 1, the common difference d is negative 2, and then we want to find the 51st term. So the nth term, we want to find the nth term of the arithmetic sequence. So that means we need to find a sub n equals a sub 1 plus d times the quantity n minus 1. A sub 1 is 6. Our common difference is negative 2. A sub n equals 6 minus 2 times the quantity n minus 1. I need to distribute that negative 2. 6 minus 2n plus 2 is negative 2n plus 8. That's the nth term of the arithmetic sequence, and now we need to find a sub 51. So I'm going to put a 51 in for n. That gives me negative 102 plus 8 is negative 94. So the value of the 51st term is negative 94. The first term is 6. We subtract 2, we get 4. We subtract 2, we get 2, 0, negative 2, negative 4. I don't want to have to do this 50 times, right? After the first term, we'd have to go out 50 more terms. I don't want to have to do that. So we find the equation, the formula that gives us the value of the nth term, and then we use that. So we find our formula first, and then here we use the formula. This way we don't have to expand it out to 51 terms. Okay, here's one for you to try. Find the 80th term of this sequence. The 80th term of this sequence. Okay, hopefully you pressed pause and you're working this out. I'm going to quickly identify the common difference as 2. The value of the first term is negative 1. A sub n is equal to 2. Got that backwards. Negative 1 plus 2 times the quantity n minus 1. Negative 1 plus 2n minus 2, which is 2n minus 3. The 80th term, that's a sub n. The 80th term means put an 80 in for n. And 160 minus 3 is 157. And that's the value of the 80th term. So now what we're going to do is we're going to move from sequences to series. And do you remember what the difference between a series and a sequence is? Well, let's go back to the first series or sequence that we had. In the very first example, it was 4, 6, 8, 10. This is a sequence. It's a list of numbers separated by commas, definitely with a pattern, and the series changes the commas into addition signs, and it becomes a sum. So that's actually something that you can calculate and evaluate. So you can come up with a single number as an answer. Now finding the sum has a formula associated with it. The sum of n terms, the sum of n terms is equal to n over 2 times the quantity 2a sub 1 plus d times the quantity n minus 1. You could also use the formula S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. So either one of those formulas works. And this is to find the sum of an arithmetic series. So that's such an important formula. I'm going to bubble it, and I'm going to bubble this one because either one will work. It's definitely either or. In fact, the one on the left comes from the one on the right. And I'm just going to show you where that comes from. S sub n equals n over 2 times a sub 1. Well, we already know that a sub n is equal to a sub 1 plus d times the quantity n minus 1. So I'm going to substitute that in for a sub n. So I get a sub 1 plus d times the quantity n minus 1. And that's where I get 2 a sub 1s plus d times the quantity n minus 1. And that's where that formula comes from. I tend to use the one on the left, but either one of them works. It all depends on the information that I'm given. So let's go there. So we've got an example. We want to find the sum of the first 15 terms of 4, 6, 8, 10, ... So find the sum of the first 15 terms of this sequence. So that means I'm going to be finding 4 plus 6 plus 8 plus 10, and then I need 11 more terms after that. Well, we're going to do this using a formula. So we can use S sub n equals n over 2 times 2a sub 1 plus d times n minus 1, or we can use S sub n equals n over 2 times a sub 1 plus a sub n. Well, let's see what we have here. We've got a sub 1, well, that's 4, okay? So we've got that one. We've got the first 15 terms, so we know what n is. And we know that d is equal to 2. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. So we know that d is equal to 2. It looks like we have more information for the formula on the left. So that's the one I'm going to use. The sum of 15 terms is equal to 15 over 2 times the quantity 2 times 4 plus 2 times the quantity 15 minus 1. 15 over 2 times the quantity 8 plus 2 times 14 is 28. 15 over 2 times 36. 2 goes into 36 18 times, and 15 times 18 is 270. So the sum of those 15 terms is 270. Okay, let's try another. Here we've got the series, or the sequence in this case, because I'm separating it with commas, and we want to find the sum. Let's do the first 20 terms. I'm going to to end up making this a big number. That's going to end up being a big number because we want to make sure that you know how to use the formulas appropriately. Most especially if you're going on to higher level math, you want to be exposed to these formulas and at least have some familiarity with them. So the sum of n terms is equal to n over 2. And if you write this a few times, you're going to have it memorized just like I do. N over 2 times the quantity 2a sub 1 plus d times the quantity n minus 1. Or S sub n equals n over 2 times a sub 1 plus a sub n. Now the one on the right is going to be perfect if I know the first and the last term. So the last term is the 20th term. Do I know the 20th term? I don't. I only know the first 4. So what do I know? I know that the value of the first term is a sub 1. I know we're looking for the sum of 20 terms, so that's n. Let's fill these in. And then we know the common difference, and the common difference here, 3 minus 7 is negative 4. So we know that that common difference is negative 4. So again, we're going to use the formula on the left. The sum of 20 terms is equal to 20 divided by 2 times the quantity, 2 times 7, minus 4 times the quantity, 20 minus 1. So that's going to be a 10 on the outside, times the quantity 14 minus 4 times 19, and 4 times 19 is 76. So 14 minus 76 is going to be negative 62 times 10 is negative 620. Negative 620, that's the sum of the first 20 terms. And that's how you use your formula to find the sum of an arithmetic series. Now, it's going to be important for you to understand that sometimes you have to manipulate your information. Sometimes you have to use your a sub n. You have to use this formula right here sometimes to find out other pieces of information. So sometimes you're going to use this formula to find a piece of information that you need for your sum formula.